All right. Hey, everyone. Thanks so much for joining us for our sixth and final session of our What's New in Solid Edge ST8 series, Electrical Harness PMI. My name is Diana Dietrich. I am the marketing specialist here at Swish Technologies, and I will be your moderator for the day. Just a little bit about Swish. For over 10 years, we've been a leading provider and partner of Siemens PLM software, and we're headquartered in St. Louis, Missouri. Our team is dedicated in providing you the best support and software, including NX, Team Center, and Solid Edge, necessary to accelerate productivity in your processes. Also, we pride ourselves in delivering process-based training solutions tailored to fit your company's needs. With our educational training services, our goal is to make you a leader in your field while staying ahead of the competition. Our presenter today is fellow application engineer Dylan Malik. For almost 2 decades, Dylan has seen the growth and changes in CAD design and has acquired a vast knowledge in topics including sheet metal fabrication, structural design, surfacing, rendering, and animation. He is a certified Solid Edge professional and training instructor with a great working knowledge of the program tool. Our agenda for the day is on wire hardness. Following a brief history of today's topic, Dylan will be providing a demonstration within Solid Edge ST8. We will then end with our Q&A session, so if you have any questions, please don't hesitate to add these into the questions box located in your GoToWebinar control panel. Dylan will have your questions answered following the demonstration. All right, Dylan, take it away.
All right, thank you, Diana. Well, thanks, folks, for taking a look. What we're going to be talking about today is wire harness. Again, it's not a well-known used portion of Solid Edge. There's only been, this is the first time there's really been any much change to it in the many years that it's actually been in the product. So the first portion of this, I'm going to show you some automated, basically wire creation. And I'm going to be doing this, I'm actually going to be using a E3 Zuken. Basically, they can output a wire harness information that we can apply to our 3D geometry by adding pins and connectors and locations to geometry. So I'm going to go ahead and run through this process. And again, it's under the harness location Solid Edge. All right, so we have this harness wizard. So, most of the time, most people usually are generating lines based on their own sketch paths and telling those to be wires or bundles, etc. In this process, we're actually going to be using, let's see, where did I actually, I had these saved earlier. Let me go grab these real quick. Here we go. So these are actually coming from the E3 Zuken. I'm going to get the file location for these so I can populate that in Solid Edge. There we go. So what I'm going to do is come out here and look for two different portions of this. First off, we have a component document, and it's an XML format. So we want to look for the CMP, which is a component portion of it. Then we want to go and copy the connection portion. So basically, it's telling it what component and what connectors on those components are going to be creating the lines for the wires. And so that's the two pieces of information I need. There's a couple things that were added after the fact, before that, after that wire path creation was or report was created. So there's a couple items we need to add. Let me minimize this a little bit so we get to our items. So there's a couple batteries, and there's a converter. And I know these two batteries are the ones I need to add to the list. I'm just going to go through and add that one. And let's go ahead and add the second battery. And lastly, let's go through and add the converter down here to the item list. Okay. All right, so the last thing is just go ahead and let the software finish it off. All right, so it's going to go through, and it's pulling this information, again, from that Zuken generated side. Of course, it works with Bentley, ePromise. There's 4 or 5 different wizards it works with. So it's pulling the information of what type of components coming from and telling what, again, what terminals is going to go to. And here's the description of the items. You can actually go in any time and change the type of line you're actually going to create right through this table. I'm just going to leave the defaults because that's what's being referred back to the list. I'm just going to say finish. And there it goes. All right, so what it did, it doesn't necessarily do a pretty job of locating the line, the actual connectors to go to the components to the actual pins that they're supposed to go to. But that's what's new about the new version of Solid Edge, ST8. They have some of these new routing paths and some splice capabilities to create line paths. So I'm going to switch over to a predefined one I've already created. Let me hide this actual sheet metal body around it. So what we have here is the exact same layout, so the same parts. I did the backside already, so I went through and said create conductors, and it actually made these components for me, but they're already in place. You notice I actually have that path right here that's kind of going through all these components. So I'm going to use these two little connectors in the front like I did in the back to go ahead and locate these little bundles. All right, so that's the new thing we have right here. So I'm going to get back into the harness, and I'm going to use what they call route. All right, so I can go and grab any of these lines. I can actually grab this bundle, and what I'm going to do is tell this bundle to locate itself. I'm going to use the cylindrical edge of this to tell it to go through this path, in this path, to go ahead and move it out of the way. And of course, it's still kind of bumping up inside there, so I'm going to go ahead and finish that off. Just going to go to my right side view, excuse me. And I'm going to go ahead and just use the manipulation tool. So for those who haven't used the wiring, we have this little, let me move this around so you can actually see it. All right, we have this little coordinate system, and that allows you to grab key points and move it in specific locations. All right, so we have the planar option. So if I want to move this planar anywhere I want, or if I just want to move it axially, I can just grab the axis. Of course, you can use your shortcut key, Z for the axis, plane, and X to lock to the, excuse me, Z for the axis, X for the plane. All right, so I'm just going to go ahead and move it planar to the Y, and then I'm going to go ahead and say, you know what, let's go ahead and move it planar and Z. All right, so that's missing everything. If you just want to look at the side view, it's a little easier to see sometimes. And let's just go ahead and just move it to the planar location. So I'm picking the plane, and this allows me to kind of move freely on a planar space as opposed to a linear movement. All right, let me move this a little bit further. That looks good right there. All right, so that's taking care of that path. And of course, we need to actually add a few components to this. We only had one motor previously created. And we have another motor here that was added to the list. Another component, notice we have that other converter that I added that doesn't have the information. So that's why these electrical wires were not created for these particular components, because there was no information to make them intelligent. So let me show you how that was done. All right, so there's no magic to it. It's really simple. Strangely, it's been in here forever, and I've seen this assigned terminals. I had no idea what it was for. Now that I've kind of gone through this wiring, some of the new stuff, I figured it out. So give it a name. Let's call this, let's just say the unit, oh, I can't type today, P149. Then we're going to assign the terminal. So I'm just going to say new, we'll call this terminal 1, and we'll just go ahead and say, well, there's two terminals on here, so we'll go ahead and create them both at the same time. All right, so I'm going to go ahead and set this terminal to use that edge right there. So it creates this little PMI dimension for me. And then let's go ahead and set terminal 2. And there's terminal 2. And go ahead and say create PMI, say OK, so I can actually use this later on. Then you'll see what I'm talking about. All right, so I created that. That's really all that wiring diagram is. So you just go through your parts and apply what connecting terminals go to what component. Simple as that. All right, so I'm going to go ahead and save that and close it back. All right, so let's go ahead and get this wired up. I can go ahead and run a path, but what I want to do is, you notice the one on the back has a little split in the actual, so they actually added a split in here and actually added it into this little bundle here. So let's do the same thing as opposed to running it straight to the actual converter here. All right, so let's go ahead and create a path. So this really hasn't changed since previous version, but before I do that, I want to create a little split on this path to actually tie that into. So I'm going to come over here and say split path. So this is new. So I'm going to go ahead and say I can just pick anywhere along this line, just eyeball it. Let's go ahead and split the path right there. And you know what? Let's go ahead and put a little split right there. All right, so the wire is going to come in here, come out this end, and continue on. All right, so now we can create our path. So I'm just going to run a few lines here. And again, I'm going to look at it at a particular front view or the side view here. That way, when I'm placing my geometry, I'm just looking at it from this view. You'll once I place it, you'll see what I'm talking about. When I go back to my ISO view, you see it's a straight line, which is fine, but again, we have these little key points in our little coordinate system. So I'm going to go ahead and say, let's move that in closer to it, and let's go ahead and drag that dot a little closer. So now that we have that position, that looks good. Go ahead and finish that off. And then we'll create another path. And this one, I'm going to come out of, rotate around so I can grab that endpoint. There we go. I'm going to grab that endpoint right there. Again, let me go ahead and reposition myself, looking straight at it, and do the same thing. And I want this to kind of come close to that connector point right there. And again, same situation. We need to move it over. So I'm going to grab the key point, tell it to move in the x-axis, and just move that down. Let's look at the top view to see how far I'm doing it. So just go ahead and keep dragging that. That should be good right there. And it's not that point. That point. Let's go ahead and move that. That should work. That looks like a little good place to put a connection into. All right, so that'll work. All right, so now let's go ahead and actually create the wires. So we're going to tell this component where to go onto this guy right here. So I'm just going to do a wire. And this is where that step that came in useful a while ago. I had the little ability to show connector information. So as I pick over components, we'll actually show you which connector item you have so you can connect it to the right location. All right, so I'm just going to go ahead and say, let's grab that point and let's feed it into that right there. And let's make it red. Make the first one red, so that's going to be a red line. And of course, I don't want it going in that direction. I want to go ahead and drag it out that direction. So you can just use this little tangent snap to kind of position it and say how much curvature you want to come out. That looks good right there. All right, so let's create the second line. And I'm going to go ahead, since I only have one more terminal, I know which one it's coming from. So I'm just going to go ahead and say, grab that terminal and do the same thing to that location. There we go. That one came out in the right position. So let's make it blue. So let's go through orange, green, gray, blue. There we go. And finish. All right. So now that I have the lines connected from where I wanted to go from to where I want to go to, let's put these inside that little area that I created. And of course, I'm going to create a little jumper area for that. So I'm going to go ahead and say I want to create a bundle and select the two items I want to be part of that bundle. And here's the start of it. So I'm going to go ahead and say I want it to go through here, I want it to go through this section, and I want it to end up coming out this section. And accept it. I like making this different color. Let's make it gray. And if I leave this blank, if I go ahead and pick which size I want, it will put it that size. But if I leave it blank, it'll actually look at the gauges of the wires and give you a little jumper area that's actually will be suited to fit all this cable. So as you can see what happened here, so these actually go to that little section there. These trim back and actually go to this section here. So the last thing I need to do to actually make these real, this is the process you always do as you're creating the lines inside of here. You just right click and say create physical conductors. Oops, actually. Pick the right one. And now you can notice we have our little jumper area in here. And of course, we're still running through the path, so if I did this right, I should be able to move this. And since it's all part of that location, it should go ahead and tell that to let me make changes without moving. So there we go. So it should automatically fall wherever you put your connector. So that's working as needed. Push that out and push back in. There we go. All right. So that is a couple new things that we have there. We also need to, I added that other converter in here. We need to connect it to this box. So I have this as a assembly. Let me switch over and open up this part here. Let me open this up. Make it a little easier to see. All right, so this is another thing that's new to ST8, the ability to add splices into the geometry. First thing we want to do is create a splice point. This is a very simple tool. You can use it on individual lines, or excuse me, wires. So I can pick a wire and tell it I want to splice a wire, but I'm going to go ahead and use this little bundle to splice it with. So I'm going to pick the bundle line. You notice I get a little dot kind of, and it's asking me where do I want to split this. I'm just going to pick that location right there. A couple different things to add as the split. I just use the default barrel splice blue. That works for me. All right, then we need to go ahead and wire this up the same way because basically it's going to the same location. We want the same connector. So just create some wires here. And again, this tool that I used earlier, I can go ahead and pick both of these. So I know these are in the same orientation. You know, this part may be mirrored or something, and I wouldn't want to reverse these. So basically, it's going to follow green, orange, yellow. So let's go ahead and create these paths. So I'll use a different connecting point here. So I'm just going to go ahead and grab that endpoint and position that. So that one would be yellow. So I know these are in the 26 gauge. They're pretty thin. So let's say, oops, that's black. Yellow, there we go. Finish that off. That's good. Again, these have tangency points, so if you want to locate these more precisely, you can. All right, let's do this last couple real quick here. Oops, do that one good. Oh, sorry, I hit escape. That was my mistake. And, all right, now we got the second one going here. And we'll make this one orange, and of course the last one will be green. Move that tangent point so it's coming out of it. There we go. All right, then the last thing to do is, since I already split that, and I just need to come over here and say create physical conductors. Oh, I knew that was going to be a problem. I screwed up the connect point down here. I actually bent that back on itself. I'd have to recreate that line, but you kind of get the idea of how that actually works. So I can split locations anywhere I want and continue on adding to them. So simple as that. Let's go ahead and close and save back to my top level. So the last thing really we need to cover is what's new in the drafting portion of it. So let me go ahead and save this assembly. We need to save that one. Let's open up the draft portion of this. So some of this was existing in the previous versions. So some of it may be new to you, some of it may not be. But we had the ability to create basically nail boards in previous versions. With some of the new technology in ST8s, we can actually label these a lot easier than we could previously. I showed this in the last week's video that I did on drafting. So how we do this is we have the ability to map to properties and to different types of reference geometry. So let's take a look at, so I have symbols, what we're looking at for under values. I want to go to wiring harness that we have on the screen, and I want to copy the name. So let me say name, and say okay. So now it actually puts that in my list. So now as I hover over the geometry, I can actually pick individual items on here if I want to easily label the wire so I know which wire is going where. Very useful tool. And again, that came out in 8. And some of the new stuff in 8 and draft, typically nailboard is drawn one-to-one. That way you can print it one-to-one, put it on a piece of plywood, put your nailboard obviously laid out so you can start creating the wire harnesses from it. For this situation, they needed a scaled version, maybe for documentation or maybe something to send to customer representation, I'm not sure. But now we can actually create scaled nailboards. So I'm going to come over here and grab an assembly. Okay, this one right here. There we go. I'm going to go say okay. So typically one-to-one is what you're going to get, but now we actually get this little scale bar. So I'm just going to scale this half scale. That should work. Yeah. And let me go ahead and reposition this a bit better. And something we actually are able to do now is actually create a conductor table for all these items. Notice we have sheet 1, which is the overall layout with the BOM, and of course sheet 2. Now we can actually create a conductor table. Let's use this assembly right here. Tell it to use hardness configuration. And when I accept it, you notice what it does. It actually kind of labels and gives me a table that actually breaks it out onto 3 different sheets. Because usually there's a lot of information in these. So we actually create individual module or individual tables now under the sheet 2 for that information. All right. That is what's new in ST8 wire harness. So Diana?
We have a few questions in our queue today. So the first one is the wiring package a third-party add-on?
The wiring package is actually built into Solid Edge. It's not accessible. I think it comes with premium, but if you have classic or foundation, you actually have to purchase the license for it to open up the licensing. So it is available. It's nothing you have to purchase to load. It's already there. You just have to have a license to access it.
Okay, it looks like we have one final question. Is there any built-in training for wire harness?
Training. Well, actually, you know what? Good question. There is some places you can look. Let's take a look, actually, because I know the help files will probably have something, but let's see what they have in the training file. So through the interface, you can go out to. I like going to the self-paced classroom because it pretty much has everything. Let's go see. Down here. Wire harness. Yeah, there is actually training files on wire harness. So for those with Solid Edge access, you do have access to get to these. And there probably is something in the help files as well. Let's actually let's see. Actually, that would be in the assembly portion of it, not where I'm at. I'm sure there's actually a harness help file too. That would kind of give you some tips and pointers.
We do have one more question, Dylan. So can blue dots be constrained?
Constrain? No, if you want to constrain a blue dot, you would actually constrain it to a coordinate system. So just create a coordinate system anywhere you want and put a blue dot on top of that. And that way it's located precisely off that coordinate system. It cannot move. Only if you move that coordinate system with the blue dot. That'd be the safest way to constrain that.
All right. Thanks, Dylan. All right, so it looks like we are out of time for the day for this afternoon. So if you do have any questions that arise about today's topic, please feel free to contact us. If you have any questions relating to utilizing the program tool, please feel free to reach out to Dylan by email or by phone. He's more than happy to help. Or if you're looking to upgrade to Solid Edge ST8, please reach out to your Swish sales representative for further information. If you don't have a Swish sales representative, you can reach out to me, Diana, and I'll be sure to direct you to a sales representative here that can work with you. All right, once again, thanks guys for attending Electrical Harness PMI. We hope you enjoyed our series. All right, thanks so much guys. Bye.
Bye-bye.